So this is the beginning of lesson 2.1.4. How can I rewrite it in graphing form? In 2.1.3, you use the method of averaging the intercepts to change the equation of a parabola from the standard form to the graphing form. And I actually worked a little bit with a couple different methods. So we did the averaging of the zeros, but I also helped in the previous video with completing the square. So we're kind of doing multiple things here. And then it's going to ask questions like, what can you say about a parabola that cannot be factored or that does not cross the x-axis? How can you write its equation in graphing form? In a previous course, you may have learned how to complete the square for quadratics, and this strategy can help you write the graphing form for a parabola. And I just love this picture, by the way, because it has a picture of a natural parabola that is formed, and it could be done with photography, but it's kind of cool looking. So we're going to move on and jump into the first part of the lesson. Okay, so this is 2-4.2, and this is part A. We have a lot to do in part A, so we're leaving it all on one slide. But here it says, write the equation of the parabola y equals x squared minus 2x minus 15. And then it asks us to put it in graphing form using two different methods. So we're going to do the averaging of the intercepts first, and then we'll use completing the square, which I did cover both on the previous video as well, but this will help cement the concepts. Okay. So first off, so we have y equals x squared minus 2x minus 15. Let's make sure you can see that's a minus. I'm going to have to factor that. So I'm going to use my diamond method, negative 15 and negative 2. Two numbers that multiply to negative 15 and add up to negative 2 are negative 5 and 3. Okay, so then I'm going to just write it in factored form. So that means our x's have to equal 5 and negative 3. So this is where we average them. So I'm going to add 5 plus a negative 3 over 2 equals 2 over 2, which equals 1. Let's put a line in between it so we don't get caught up in all the work. This is the x of our vertex. Okay, now to get the y of the vertex, we're just going to plug the 1 in to the original. It's a little easier. And so that becomes 1 minus 2 minus 15, so y equals a negative 16. Okay, so that's the y of our vertex. Okay, so our vertex is, and that is 1 and negative 16. So that's our vertex. So that's one answer we needed. They also wanted our x-intercepts, and those are at 5 and negative 3. Typically, I would write it out in coordinate form. Oops. Okay. But then the last thing it needs for this is what the y-intercept is. So if I'm looking for the y-intercept, I would set the x is equal to 0 because that's what x is when it's the y-intercept. Okay, so our y-intercept is going to equal negative 15. And that means we would say 0, negative 15. So there's your y-intercept. Okay, when we do the complete the square, it's also going to be the same, but it's just a different way. And I think when we do complete the square, you might find that it's less work. But let's go ahead and write it also in their graphing form. Okay, so we've got our y-intercept. And now the graphing form is using our vertex. So y equals x minus 1 squared minus 16. That's the graphing form of the equation. Okay, and we'll graph it later after we do completing the square. And I'm also going to just circle these so you see where the work is done. All right, and then now what we're going to do is we're going to move on and we're going to show the completing the square method. And then we'll put the graph up so we can talk about the parts of it to make sure that we've done everything correct. Here we go. Okay, so now we're going to show the completing the square for this one. Now, on completing the square, what we're looking for is the constant. We're looking for what C would be, because right now we could actually just factor this and it'd be really easy, but we're going to complete the square just to show what our work is. We're going to add 15 to both sides. And then I always add a blank, because this is the part where we complete the square. Remember, completing the square is b over 2 squared. That's what goes into this blank. So in this case, it's going to be negative 2 over 2 squared. Okay, are you with me? So that means it's going to be y plus 15 plus 1 equals x squared minus 2x plus 1. All right, that means the left side is y plus 16. The right side factors to x minus 1 squared, okay? Then we do the last thing, which also gets this into the graphing form. And this is why sometimes this is just easier, because this tells us that our vertex is 1, negative 16, okay? And so we've already talked about what the y-intercept is. We've already talked about the vertex of the parabola is right here. And so we're just going to write all of these out here. So we have our vertex, and I'm going to do it in a different color so we can summarize and then show the graph. Vertex was 1, negative 16. X-intercepts are negative 3, 0, and 5, 0. And then we have our y-intercept, which was at 0, negative 15. And then last but not least, we're going to actually show you a sketch of the graph, and that will end the problem. So let me grab that. Okay, and so now what we have here is we've proven our negative 3, 0 and our 5, 0. We have our vertex at 1, negative 16. We have our y-intercept at 0, 15. And that pretty much ends 2-4 too. On this particular one, I probably would have, I think I would have completed this square just because I think it would take less time and a lot less work. But both methods work on this one because this is also a factorable quadratic. So let's move on to the next slide for part B, and I believe C. Okay, so this is 2-42, and we're going to do B and C on this particular one, but let's take a look at B. I actually put the graph here so you can see it. There's the B graph. And the reason I'm showing you this is I want to also have this there so I can explain to you why I am choosing the method I am choosing. Both of my intercepts are rounded to the nearest thousandth, okay? That to me is not going to be something I can factor because first of all, there are not two numbers that multiply to 10 and add up to 8. So it's not going to be easy to do anyway. So I'm going to choose to use the completing the square. So I'm going to subtract 10. I'm going to put a blank in. And I'm going to put a blank here as well. And remember, the blank is b over 2 squared. So it's going to be 8 over 2 squared and 8 over 2 squared. So I've got y minus 10, and that 8 over 2 is 4, squared is 16. Then x squared plus 8x also plus 16. Okay, now combine like terms on the left, so it's going to be y plus 6. And then factor the right so that it's a perfect square. So all you have to do is divide 8 by 2. So it's like what our b was divided by 2 without squaring it. If you understood what I just said, notice it's 8 divided by 2 is 4. So x plus 4 squared. Now, to put it in graphing form, we're going to move the 6 over. And so our vertex is -4, -6, which we have right here. So we're just proving what we have on the graph, okay? And then the y-intercept, you can't see the y-intercept, but I'm going to do that in blue. So, but that means that the x has to be 0. Okay, and plus 10. So that means our y-intercept is going to be at 0, 10. And it doesn't show on the graph, but that's where it's headed, okay? So we have that. We know the zeros, but we couldn't use them for factoring. So these are our zeros. All right, and that pretty much ends part B. And I would not say both strategies work for this. I would not use the averaging of the zeros for this because of what they actually are. This particular quadratic would have to be solved using the quadratic formula. So let's move on to the next part. So for part C, this is one of the reasons I really like to look at graphs on the graphing calculator, because if you're supposed to discover all of these things and you're supposed to learn these things, it helps to also use the tools around you. And one of those tools that's powerful is the graphing calculator. A lot of the ones I'm doing are in Desmos, but the TI-84 is really important to learn how to use too. But this is Desmos. It allows me to label things a little bit easier and quicker. So, but you can see here, if we're looking at this area here isn't even touching the x-axis. So our vertex is above the x-axis. So you're not going to be able to factor and use the zeros to average the intercepts because there are no intercepts. So we really do need to use completing the square. So I'm going to just go ahead and do that. So we're going to subtract 4, leave our blank. And remember, again, our blank is b over 2 squared. So that is 2 over 2 squared and 2 over 2 squared. All right, so that's y minus 4 plus 1, because 2 over 2 squared is 1, and then x squared plus 2x plus 1. Now, on the left, we're just going to combine like terms. On the right, we're going to factor. Remember, we can do x plus 2 divided by 2, so that's 1 squared, because 1 twice adds up to 2. So 1 times 1 and 1 plus 1 adds up to 2, if that makes sense, if you're using the diamond method. Okay. Last thing you're going to do, and this is going to put it in graphing form, x plus 1 divided by 2 plus 3. Now, that confirms that our vertex is at -1, positive 3, which we have right here. Okay, we don't have any x-intercepts, but we do have a y-intercept, which we can also prove, which is 0 squared plus 2 times 0 plus 4. It means y equals 4. So our y-intercept is 0, 4. Okay, and that pretty much tells you that. Both strategies do not work on this one either. So hopefully that helps, and we'll now move on to D. So this is just a discussion screen, and I might doodle a little bit, but I put up 3 examples of graphs that I think will help with our discussion. It's not really a discussion. It's me talking, you listening. Hopefully you're listening. Hopefully you enjoy this. All right. When does the method of averaging the intercepts work better? I think really when you have a graph similar to this one, because we have actual zeros there. Okay. We have -3 and we have 5. And so then you can average them. It makes it easier to work with. If you look at graphs like this one, it's going to take the quadratic formula to solve it. So if you're going to complete the square to find the vertex, that's going to be more efficient, I believe. And then also on this one, when there are no zeros, no real zeros. Okay, because it does not cross the x-axis, so there's no x-intercepts. So therefore, it's easier to use completing the square. My personal opinion is that completing the square is more efficient, because once you're done with completing the square, you also have the equation in graphing form. And that just makes life a little bit easier to begin with. Okay, so that is my opinion, and I'm moving on. Okay, so for this problem 2-43, we're also going to go to a video in a moment to help you figure out how to use the tiles, the algebra tiles, to move things around and figure out how to complete the square. But at this point, let's just talk about this. Jessica was at home struggling with her homework. She had missed class and could not remember how to complete the square. She was supposed to use the method to change f of x equals x squared plus 8x plus 10 to graphing form. Then her precocious young sister, Anita, who was playing with algebra tiles, said, "Hey, I bet I know what they mean." Anita's algebra class had been using tiles to multiply and factor binomials, and Anita explained would look like this. So the video we're going to show is going to show you how you can take all of this information and figure out how to put it in a form that would help you with completing the square. And it will also help because we're going to actually solve it by completing the square algebraically as well. But you can see here, they've already started by moving the x squareds over. So you have the 4x here and the 4x here. So that makes for the 8x's. And then you have to use the remaining ones they have here to add the 10 in. Okay, so there's 10, but there's this empty space here, and that's the important part. So we are going to move on and talk about that after you watch a little video as well. Okay, so this is going to be the finishing of 2-43, and we are going to show you a video about how these algebra tiles work with this particular problem. But if you remember, our original is x squared plus 8x plus 10, which we have right here. Okay, and in this particular equation over here, you have x plus 4, if you're completing this, with an x plus 4. And if you multiply that out, x plus 4 times x plus 4 is going to be x squared plus 8x plus 16. But our original is plus 10, not plus 16. So that means you're going to have to subtract 6, which is exactly what happens here, because we have 6 extra blocks that weren't given to us in the building of with the algebra tiles. So that is essentially by saying x plus 4 squared, which is this, okay, minus 6 equals x squared plus 8x plus 10. And we will confirm that with a graph in just a moment. But let's show you the video first for the algebra tiles that comes with a CPM e-tool. Okay, so this is the e-tool that they give you. And so we're going to go ahead and build it. So here's our 1x squared, which is in our equation here. Here's our 8 x's, which we have here. And here's our 10 single units, which will add up to the 10 that we have here. So this is how we came up with our equation and how we were able to complete the square by looking at the diagram of these particular pieces. So we've got 4 x's here, and we've got 4 x's here, which makes it 8x. Sorry, they're not like sticking together there. Come on. All right. And then we have 10 to place, okay? And I'll place those as quick as possible. Okay. And then you'll see what is left and how we come to the equation that we came to with the minus 6, okay? If you see there, this is putting all of our equation in. And to complete the square, we've got 6 missing here. But if we do x plus 4 times x plus 4, which we talked about, that becomes x squared plus 8x plus 16. And we only have 10 single units. So that means we have to bring over this one and change it to a negative. This changes to a negative. And these are the minus 6's that we were talking about earlier. So you can use this e-tool to help you figure out how to solve these equations. And it's kind of nice using the algebra tiles because it illustrates it. So it helps you understand what a perfect square actually means. Okay. Okay, so this is just a quick video to prove that both of these equations are equivalent. So you'll see that I have x squared plus 8x plus 10 actually graphed. And then the reason I don't have the other one already typed in is I want you to see what happens and where the minus 6 comes in. So we have x plus 4, and we're going to square it, okay? So look at that. So, but then we do a minus 6 to it because remember, it's not a complete square at x squared plus 8x plus 10. So we do minus 6, and once I hit 6, you're going to see that green go away and it's going to become purple. And that proves that they are equivalent. So that's all there was to this video. Thanks. Okay, so we have a video to work out the squares, but I thought it would be good to go through the completing of the square for this particular problem. So let's just jump into that. So y equals x squared plus 4x plus 9. To complete the square, I'm going to move the 9 over. Got my blank there. Plus my blank here as well. Remember, that's b over 2 squared. So I'm going to put my 4 over 2 squared in both spots, because whatever you do to one side, you have to do to the other in algebra. Y minus 9 plus 4, because 4 divided by 2 is 2, and that squared is 4. So x squared plus 4x plus 4. So this one we go y minus 5, and then we factor this to x plus 2 squared, because remember it's just dividing that b term in half. Then we're going to move over the 5, and we'll have it in graphing form. So our vertex is at -2, 5. Okay, now let's look at, so it says, draw the tiles to help her figure out how to make this expression into a square. Does she have too few or too many unit squares this time? Write her equation in graph form. We're actually going to pop in a video here that goes through the tool that they gave us for this unit and actually solves that for it. So in this particular question, we're trying to help Jessica figure out how to complete the square using the tiles, and then we'll prove it algebraically as well. But first of all, I've got the equation here, x squared plus 4x plus 9. So I have 1x squared, I have 4 x's, and I have 9 individuals. So I'm going to come here and I'm going to go x squared, and then 2x, and then 2x. Okay, then I'm going to put my other 2 x's here, so that takes care of my 4 x's. So I've got my x plus 2 and my x plus 2. And if I fill it in, I'm going to have 1, 2, 3, 4. Okay, so I have x squared, so it's x plus 2 times x plus 2, which becomes x squared plus 4x plus 4. I have all these others out here because the equation was plus 9, okay? So what that does is it means now we have our perfect square of x plus 2 squared, and I'm going to go ahead and bring this up because this is the actual answer for that. We have our perfect square of x plus 2 squared, and then we have 5 extra. So we do this as plus 5, and then we have it in our graphing form as well. And that is all there is to setting it up with the tiles. And now we will verify that by doing it algebraically on the slide. So that ends the video. That really also ends the problem because we had already verified that algebraically. I just did them in a different order. So moving on to 2-45. So this is 2-45, which is a little bit different than the others. But rather than using the algebra tiles this time and creating a video, I'm just using the images that they came up with. But Jessica decided to use force to cut one of the x's in half because we have x squared plus 5x plus 2. So that's not going to be an easy one to solve. So in the diagram, you see how she's cut one in half. Let me get a pen. Through here, you see this. And down here as well. Okay. So she's got x plus 2.5 squared. Now it says on there how many unit tiles are in the perfect square. There are only 2 single units because of the 2 in the equation. Does Jessica have too many or too few in her original tiles? She has too few. And if you go through and you count these, let me get green for this one. You have 1 with these 2, 1 with these 2, and then this one and this one. So that's 4. And then you have a quarter. So that's going to be 4.25. Okay. She had 2, like we answered for part A. Then it says write the graphing portion of the function. Well, we have our x plus 2.5. So that's going to be y equals x plus 2.5 squared. And then it's going to be minus what we don't have in this particular portion of it. So minus 4.25. Now, if I was to actually complete the square, let's assume that's what they mean by part D, I would write it out as y equals x squared plus 5x plus 2. I would subtract 2, add a space, add a space. It's becoming very difficult for me to do that. Okay, and then I'm going to do my b over 2 squared, which in this case is 5 over 2 squared, which equals 6.25. So I'm going to put 6.25 in each blank. Oops. 6.25. Okay. And then I'm going to factor the right side. So it'll be x plus 2.5 squared. Then I'm going to combine like terms here. So that's going to be plus 4.25. And then I'm subtracting, and it gets us into graphing form. Minus 4.25. Okay. And what I'm going to do now is show you a video, a really quick video of the two graphs put together and how they are equivalent. Okay, so this is me showing that the two graphs that we came up with were equivalent. So you'll see here that I have the original x squared plus 5x plus 2 graphed. And if you come over here and look where the vertex is, that is at negative 2.5 and a negative 4.25, which is what we actually figured out. But let's just make sure that our graph that we actually came up with also fits. So that's going to be x plus 2.5 squared, and notice it's lining up, and now all I have to do is put the minus 4.25, and once the purple shows up, the green goes away, and you know you have the same equation. And that is proving that what we did with the decimals is correct, and these two equations are equivalent. Okay, so for this particular problem, I decided not to go through and walk through every solution because it just takes a lot of time, but you can see all of my steps here. I really did choose on all of these because I couldn't factor them for zeros. I chose all of them to complete the square. So that is just my choice. That is usually my go-to anyway. So you will see the solutions there for completing the square on all 4 of these. Okay, and you'll notice that some are a little different, these two in particular, because you're not dealing with nice, neat integers with your completing the square, but they still work. So moving on. Okay, so it's asking us to be able to look at a graphing form of an equation and figure out how do we graph a parabola using that. Well, the first thing I'm going to do is I'm going to take that equation and figure out my vertex. Well, that's a positive 3 and a negative 25. So I'm just going to plot my point of 3, comma, negative 25. Okay, and then close parentheses. So let's take a look at where our graph is. There we go. Okay, so when I do that, I also want to draw the axis of symmetry. And I've talked about this before, but the axis of symmetry is always the vertical that goes through the x. So I'm going to go ahead and type x, and this will give me a vertical line, x equals 3. All right, then we have our vertical line through that particular point. So now I'm going to choose points on either side, and this is 3. So I'm going to go over here and I'm going to choose, oh, I don't know, let's choose 1. Okay, so if I plugged 1 in, it would be 1 minus 3, which would be negative 2. Negative 2 squared would be 4. 4 minus 25 would be a negative 21. So we're going to say 1, and you could do all this math on scratch paper, 1 and then negative 21. So we have another point, okay? Now I am 2 way away from the axis of symmetry, so I'm going to go 2 to the right of the axis of symmetry, and that will be 5, negative 21. So I'm going to plot another point. 5, oops, I need to put parentheses around that. 5, negative 21. And we have another point, okay? And I typically would pick another one, and since we need to know the y-intercept anyway, I'm going to go ahead and pick 0. Okay, so 0, if I plug that point in, I'm going to put 0. And, well, first I'm going to go like this. I keep forgetting to put the parenthesis in. Okay, 0, and then I'm going to go up and look at my equation. If I plug in 0, 0 minus 3 is going to give me a negative 3, and negative 3 squared is 9. 9 minus 25 is going to give me a negative 16. So I'm going to come down here and I'm going to put a comma, negative 16. Okay, and close parentheses. All right, and you can kind of see what's happening here. I'm 3 away from the axis of symmetry, so I'm going to go 3 more over. So that's going to be 6, negative 16. Okay, so let's plot that. Now I could do this all with a table, but what I'm trying to show you is how you can do each point at a time, and then we're going to go back up and we're going to go and hit the line that we have up here. I'm going to unmute it. Right now it's muted. So if I've done everything correct, I should have, I first of all have a vertex at 3 dash negative 25. But now I'm going to go ahead and hit graph. And you can see that's an easy way to go ahead and graph the equation. And we'll move on to more parts of this particular problem. Now that we have finished by graphing it, and we know that our y-intercept, we're going to go ahead and write those down. Our y-intercept is 0, 16. I think, no, yep, 0, negative 16. I'm sorry. Wasn't looking at it quite correctly. We also know our vertex is 3, negative 25. Now, I'm going to go ahead and start with this, but we've got to find our x's, okay? And I don't even show the x's on here, but we're going to figure out what that means. So we have x minus 3 squared minus 25. Now, I do this a little differently than CPM does, but you can do it the CPM way too, where you add 25, take the square root, and you've got 2 equations to solve. But what I do is I first start out by FOILing. So then it becomes y equals x squared minus 6x plus 9 minus 25. So then that takes me to y equals x squared minus 6x minus 16. Okay, and then I factor it. Okay, and I use that diamond method. So I've got a negative 16 and I have a negative 6. What, 2 numbers multiply to negative 16 add up to negative 6? That would be negative 8 and 2. 2 times negative 8 is negative 16, and negative 8 plus 2 is negative 6. So then I would have x minus 8 and x plus 2, which means I've got x equals 8. So that is 8, 0. And I have x equals negative 2, and that is negative 2, 0. And that pretty much finishes everything for part A. We'll go on to part C and do the same thing. Actually, not part C. We will be going to part D because the CPM resource page does the problem differently than I do, and you will be able to follow along on that in class. So part D I will do, which is similar to this. And that's it. Okay, so this is part D of the last problem we're doing on this help video. And part D is very similar to part A. And what we're going to do is we're going to graph it based on the graphing form of the equation, which we have here. So the first thing I need to do is I'm going to graph my vertex. And based on the x plus 5 up here, I know that my x of my vertex is negative 5. And then I'm going to put a comma, of course. And then my vertical is minus 8. So I'm going to put a negative 8. Okay, that gives me my vertex right here. So we're going to label that. I'm going to go ahead and label it. All right, then I need to find my axis of symmetry. Well, my axis of symmetry is a vertical line that's going to go through the x value of my vertex. So that is x equals negative 5. There's my vertical line, okay? Now it's time to plot a few points, and then we'll go ahead and unmute this equation and see if we've done it correctly. So I'm going to pick, since I have to find the y-intercept, I'm going to go ahead and start by putting in a 0, comma, and then I'm going to go to this equation, and 0 plus 5 would be 5. 5 squared is 25. 25 minus 8 is 17. So that means my y value of that coordinate is 17, and that's my y-intercept. Can't see it very well, so let's move it down a little. There we go. All right, and as you can tell up here, I'm 5 away from the axis of symmetry, so I need to go 5 in the other direction to get another point that corresponds. And that would be at negative 10, 17. Okay, and you see that point. Now I need one more, just because I typically have students plot at least 3 on each side of the axis before they do their final graph. I'm going to pick a -3. I'm going to plug that in, but first I got to get it started. So -3 is my x. And then I'm going to go put that into the equation. Well, -3 plus 5 is 2. 2 squared is 4. 4 minus 8 is a -4. So that means we're going to have a -4. And as you can see, I'm 2 away from the axis of symmetry, so I need to go to the opposite direction for the final point I'm going to plot. That means it would be -7, -4. Okay, there's my last point. So we have the vertex and we have the points on either side. And what I'm going to do now is I'm going to go ahead and click on the equation to see if we are correct. I'm also going to label this because that's our y-intercept. Let's come down here and label that. Very good. And let's go ahead and unmute the equation. Now you can see what's happened here is we plotted everything correctly. We didn't need to use a graphing calculator to graph it. We just graphed it with the information that we already know. And so that's all you need to know on this particular problem. But now we're going to go prove it algebraically so that we can find out what our x-intercepts. And just for the heck of it, let's look at what they look like right here. Okay, that's -2.172. That's interesting. So, and then here, -7.8280. So we'll see what that does when we actually plot it. Here we go. So as you could see, when we closed out of our video for graphing this particular problem, I had some interesting looking zeros. So when I came back to the equation, I actually expanded out. I did y equals x plus 5 times x plus 5 minus 8. And that actually worked out to x squared plus 10x plus 17 when I combine the 25 with a -8. And there's no way there's not two numbers that multiply to 17 and add up to 10. So this tells me, and so did what we saw on the graph, that I need to use the quadratic formula. So I'm going to start by erasing this to give myself a little bit of room. If I can get the right sized eraser. Actually, there's an easier way to do it, but since I'm in the middle of it, I'll just continue. All right, let's get back to it. So here's the quadratic formula. I'm going to take the information that I got from my x squared plus 10x plus 17, and I'm going to plug it in, okay? So x equals, and it's going to be a -10 plus or minus 10 squared minus 4 times a, which is 1, times c, which is -17, or positive 17. All over 2 times a, which is 2, because a is 1. All right, so then we get here, and it's x equals -10 plus or minus 100 minus 68 over 2. Then we have x equals -10 plus or minus the square root of 32 over 2. And that goes to -10 plus or minus 4 root 2 over 2. Because the square root of 32, let me take this up here for those who struggle with that. The square root of 32 is the same as the square root of 16 times the square root of 2, which equals 4 times root 2, which is what we have on our equation right here, okay? Then I can factor out a 2. So I'm going to factor out a 2. And let's actually take this over. So we're running out of a little room. So I'll do this. And x will equal a -2, or just a 2, outside a -5, plus or minus 2 root 2, all over 2. And those cancel. So your final answer is -5 plus or minus 2 root 2 for your x's. That's for your x-intercepts. We already figured out our y-intercept is at 0, 17. Yes. And then our vertex is at -5, -8. And then there, and also when you plug these equations into a Texas Instrument or any kind of calculator that can handle it, you will get both of those x-intercepts. All right. And the difference is this is exact, which is what they wanted. Exact is simplest radical form. All right, that ends this help video. Once again, if you like this video, please give me a thumbs up. And if you are wanting to follow and get more of these videos, please subscribe. We could use all the help we can get, and we'll see you on the next video. Also, don't forget, if you've got questions about the math, you can put them in the comments and I will get back to you. All right, have a good one. See you next video.